All right, the following diagram shows circle center O, radius 15, arc ACB subtends an angle of 2 radians. Find the length of arc ACB. So the length of an arc is r theta. So we've got r is 15, theta is 2, so we're 30, and that's centimeters. And B, we have the area of the shaded region, that's 1/2 r squared theta. So it's going to be 225, except that that's the area of this. So we have to do, I just saw 4 marks, the area of a circle, pi r squared, minus the area of that sector, which is 15 squared. And we could take 15 squared out, and it's pi minus 1. So 225 pi minus 1. All right, for 8, we've got circle radius 5. And find the perimeter of the shaded region. So that's going to be 5 plus 5 plus the length of an arc. And we can do, so this here, if that's 1 radian, we know like a whole circle is going to be 2 pi. So we can just subtract 2 pi minus 1, and that's going to be that red. So the length of this arc here is going to be r theta, and theta is 2 pi minus 1. So that's going to be about 36.4 centimeters. All right, we've got 2 concentric circles with center O. The radius of the smaller circle, is 8. 10 is the radius of the larger circle. Points A, B, C are on the circumference of the larger circle such that AOB is pi over 3. Find the length of arc. So we want that. So that's R, which is 10. Theta, which is pi over 3. So 10 pi over 3 centimeters, or whatever. Yeah, centimeters. And then find the area of the shaded region. We're going to have the area of the large sector subtract the area of the small sector. So large sector area is 1/2 r squared theta, minus smaller sector is 1/2 8 squared theta. So that's 100 over 2, which is 50 pi over 3, minus 64 over 2 is 32 pi over 3. So we're going to have 18 pi over 3, 6 pi. All right, circle with center O has radius 3.9. Points A and B lie on the circle, and AOB is 1.8. Find AB. So this is cosine rule. We've got x squared equals 3.9 squared plus 3.9 squared minus 2ab cosine 1.8. Make sure your calculator's in radians. So that means AB is 6.11 to 3 significant figures. In the area of the shaded region, we have, so the rest of this is 2 pi minus 1.8, because the whole, yeah, it's fine. And then we have, so that's theta, so we have 1/2 r squared the angle, okay? And you get about 34.1, and that's centimeters squared. All right, O is the center of a circle with radius 5.4. The area of the shaded sector is that. Find the length of the minor arc. So that's the smaller arc here. So we've got the area is this. That's equal to 1/2 r squared theta, which we're looking for. And once we find that, we're going to have 5r theta for the length of the arc. So theta ends up being 1.48, and then the length of the arc ends up being, when we substitute that in there, 8. Okay, so we have a diagram as above with circle O, radius R, shaded sector OAB has area 27. Okay, so instead of this being 5.4, we've got the area this time is 27, and the angle is 1.5 radians. Calculate R. So we're going to have 1/2 R squared theta, which is 1.5, equals 27. So you end up getting R as 6. Calculate the length of the minor arc. So we're going to have R theta, so 6 times 1.5, which is 9 centimeters and centimeters. No, sorry. Centimeters and centimeters. All right. The length of the arc is 3 pi, and the angle is 2 pi over 9. Find the value of R. So we've got 3 pi equals 2 pi over 9 times R. So we're going to have 27 over 2 to be R. And the perimeter of the sector, so we're going to have 27 over 2, twice that, because that's 2 radius plus the length of the arc, 3 pi. So we're going to have 27 plus 3 pi. And the area of the sector is 1/2 R squared. Theta is 2 pi over 9. So that's 4,872 over 27 times 27 times 2 pi. So that's 36, and 9, 3, and 4. So that's 81 pi over 4. And that's centimeters squared. All right, we've got this diagram. Area of the sector is that. Length is that. So we have 1/2 R squared theta is 4 pi over 3. And we have R theta is 2 pi over 3. So I can substrate into here. If that's 1/2 R times R theta, which is 2 pi over 3, equals 4 pi over 3. So 2's cancel. And then if we multiply by 3 over pi, that will cancel. So R is 4. And that means that 4 times theta is 2 pi over 3. So theta is going to be pi over 6. So we've got the area of the sector is that. So 1/2 R squared theta is 180. And then R theta is 24. Same deal here. 1/2 R times theta equals 180. So 12. 180 over 12. And that goes in 5 times, which makes theta 24 over 15 and 8 over 5. All right, diagram below shows circle radius 15. The angle at the center is 2 radians. Calculate the area of the sector. So 1/2 R squared theta, so that's just 225 is the area of the whole thing. From that, for B, we have to subtract the area of the shaded region, which is going to be 1/2 AB sine theta. Okay? And this ends up being 123 to 3 significant figures. 17, the following diagram shows a sector of circle radius R theta. Perimeter of the sector is 20. So we have R plus R, so 2R plus r theta is 20, and we need to solve for theta. So we're going to have 20 minus 2r over r. So that's A. The area of the sector is 25. So we have 1/2 r squared theta is 25. And we need to sub in theta. That's 25. So one of these r's is going to cancel. And we could write 10 minus r and cancel the 2. So we're going to have, when we distribute the r, we're going to have 10r minus r squared is 25. And this is quadratic. So we're going to have 0 equals factored r minus 5 squared. So r is 5. Alright, the diagram shows this radius 5, angles degrees now, so you got to change your calculator. 135, find the area of the shaded region. So this one, we need 1/2 AB sine 135, and that is just the triangle. And we need the whole area of the sector, which is 1/2. You can think of it as part of the area of, so either you can change it, the 135, into radians, that's fine, and then just use 1/2 r squared theta, or you can think of this area of the whole sector as part of the area of the circle. So we can do 135 out of 360. We just want that portion of the circle area, which is pi r, which is 5 squared. So that's another option. So you should get 20.6 centimeters squared. Yeah, 19. So the length of the arc, so r theta is 2r. And the area of the shaded segment, so that's going to be 1/2 r squared theta minus 1/2 r squared sine theta. So the area of the sector minus the area of the triangle, and that is equal to kr squared. So, okay, this is not bad at all, because if we divide by r here, we get theta's 2. We can also do the r squareds out, because everything has an r squared. And we'll have 1/2 times theta, which is 2, minus 1/2 sine theta, which is 2, and that's equal to k. So this is 1 minus 1/2 sine 2 equals k. Okay, so here the diagram shows circle with radius 1. The area of triangle AOB is 3 times the shaded area. So we have the area of triangle AOB is 1/2 r squared, which is 1, sine theta. Okay? And then we have that is 3 times the shaded area, which is the area of the sector, 1/2 r squared theta minus the area of the triangle, which is 1/2 r squared sine theta. Okay, so we're going to have 1/2, sine theta equals 3, and then we have 1/2 theta minus 3, 1/2 sine theta, and if we distribute 3, we're going to have 1/2 sine theta equals 3 over 2 theta minus 3 over 2 sine theta. So if we add the 3/2 sine theta over. That's going to be 2 sine theta equals 3/2 theta. And then multiplying by that 2 gives us what we want. Find the value of theta. So this is with graphing calculator and NSolve or the graph. So when you do this in the graphing calculator, make sure you're in radians first of all. And then when you just put it in comma x, it gives you 0, but it says up here that it can't be 0. So I just put after x comma 0.001, and it gives that theta is 1.28 radians. The diagram above shows circle O, radius R, AOB. The ratio of the shaded area to the area of the triangle is 2 to 5. Okay, so we have 1/2 r squared sine theta. That's the area of the triangle. And that is twice 2 and this is, I guess, yeah, what we could do is, instead of doing that, so if we do like, then the area of the shaded part is 1/2 r squared theta minus 1/2 r squared sine theta. And this area, so the ratio of the shade area, so this is 2 to 5. So that's, then you can cross multiply. So that's why this is twice and this is 5. And then this will cancel. So we'll have r squared sine theta equals, and I'll just go ahead and distribute 5 over 2 r squared theta minus 5 over 2 r squared sine theta. And when you add that 5/2 sine r squared sine theta over, we're going to have 7/2 r squared sine theta equals 5/2 r squared theta, and then just multiply through by 2, and we can divide by r squared. So we're going to have 7 sine theta equals 5 theta. All right, 22. In the diagram, O is the center and AT is tangent at T, so that means it touches the circle once at T. If OA is 12 and the circle has radius 6, find the area of the shaded region. Okay, so basically we need, so we need the area of this triangle, subtract the area of the sector. So we're going to have 1/2 r squared theta, which we don't know. That's the area of the sector. And then we need to subtract that from the area of the triangle, which is 1/2 AB sine theta. Oh, this is a right triangle, actually. I was going to say, how do we know? So actually the area of the triangle is going to be, we need to use Pythagoras. So 6 squared, this whole side length is x, plus x squared equals the hypotenuse squared, 12. So when you do that in the calculator, you're going to get square root 108. We'll simplify at the end. So that's the length of x over here, square root 108. So the area of this triangle is 1/2 base times height, 6. So now we need to use like SOHCAHTOA to find out this central angle here. So we have the adjacent and the hypotenuse, so we're going to use cosine theta is 6 over 12. So this is 1/2, and cosine is 1/2 here at pi over 3. So actually here we can replace with pi over 3. So this is going to be, 1 second. So this cancels to be 3, and this is 6 root 3. I did in the calculator. So 18 root 3. And then we have 36 over 2 is minus 18 pi over 3 for the area of the shaded bit, also known as 6 pi. Okay, 23. The diagram below shows a circle of radius 5 centimeters. Okay, and points A and B are on the circle. AOB is point A, N is on OB such that AN is perpendicular. Find the area of the shaded region. Okay, so we need to do 1/2 r squared theta. That's the area of the sector. And we have to subtract the area of this triangle, white triangle. So we need this one, and we can use 1/2 AB sine 0.8. So to figure out x, we have that's the adjacent and hypotenuse. So we'll have cosine 0.8 is x over 5. So x ends up being 3.48353, which we put that in there. And when we do this whole thing, you get 3.75 centimeters squared.